Hello everyone and welcome. Today we're continuing with part 3 of the series on preparation of alkenes. And as we know, alkenes contain carbon-carbon double bond. In today's reaction, we're looking at hydro-halogenation. That means you're adding H and X, where the halogen is X, where X can be chlorine, bromine, iodine, or fluorine. So you're adding hydrogen chloride, hydrogen bromide, hydrogen iodide, or hydrogen fluoride to triple bonds. So alkynes are triple bonds that contain carbon-carbon triple bond. So we're starting with carbon-carbon triple bond, and then we add HX, and we end up with carbon-carbon double bond with now the hydrogen and the halogen added across the double bond. So added across a triple bond, so these triple bond carbons, and now it reduces it to double bond, this one here. So the first example will be this alkyne. Let's count the number of carbons. We have 1, 2, 3, and 4 carbons. Remember, in skeletal structure, each corner is a carbon. And now we are focused on the alkyne carbon. So that and that, those are the two alkyne carbons, where this carbon-carbon triple bond is the alkyne functional group. And then you react that with, say, for example, hydrogen chloride. So HCl, you end up adding H and Cl across the triple bond. And when that happens, you lose one of the triple bond carbons, and now you add the H and Cl across the triple bond, but addition is Markovnikov. That means the hydrogen adds to the carbon with the most hydrogen, so that carbon number 1 has 1 hydrogen, but carbon number 2 has 0 hydrogen, and therefore hydrogen adds to the carbon number 1, which has the most hydrogen. So you end up with a hydrogen there, and then chlorine adds to the other carbon. Now, if you have a study material that looks like this, where we have carbon number 1, number 2, number 3, number 4, and number 5, you'll see that the triple bond carbons are carbon number 2 and number 3, but each of those have no hydrogen. So 0 hydrogen and 0 hydrogen, meaning that there will be no preference in how you add the HCl, so there is no selectivity. So in this case, when you react that with HCl, then just like what we saw with the first reaction, you end up reducing the triple bond. So you end up removing the triple bond in both cases. But now you add H and Cl across the double bond. So in the first case, you add hydrogen and Cl across the double bond, hydrogen to carbon number 2 and Cl to carbon number 3. And in the second case, you actually have opposite. You have hydrogen added to carbon number 3 and the Cl to carbon number 1, to carbon number 2. So you end up with a mixture of products. So we say no selectivity in that case. Thank you very much for your time. Please support the channel by subscribing and stay tuned for the next section.